Mrs. Banky here. The goal of today's lesson is to teach you about what is called the mole in chemistry. And as you can see up here on the learning objectives, we're going to define mole and talk about what that means in chemistry. We're going to learn how to calculate the molar mass of a substance and also how to calculate the percent composition of a substance. So that is the goal of today's lesson. By definition, a mole is a counting unit used in chemistry and just like 1 dozen equals 12 or a pair equals 2, the mole is a counting unit. So 1 dozen equals 12, 1 pair equals 2, 1 mole is equal to, wait for it, it's a really big number, 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. This number is also called Avogadro's number. Not avocado, Avogadro's number. And the video that I'm going to have you watch will describe the role of Avogadro. Now, in the second video, the TED Ed video, he talked about using, going to the market to get salami and how it's bought in pounds rather than slices. And we have a connection between mass and moles in chemistry that's very useful to us because we don't have any little machines that sit and counts atoms one by one. So we have an electronic balance that gives us the mass. Now, the unit that's useful to us is something called molar mass. And the molar mass of a substance is equal to, it's equivalent to the atomic mass, which can be found on the periodic table, in grams. So So again, it's the molar mass is equal to the atomic mass of a substance in grams. For example, as I look up on the periodic table, I know that you can't see this right now, but I'm looking. I see that the atomic mass of copper is 63.55. So the atomic mass of copper equals 63.55. Again, that number's coming from the periodic table. So 1 mole, and mole is shortened. The unit for mole is shortened to MOL. I know that that's not shortening it very much, and I have it in cursive here, so I'm just going to get rid of it in cursive. So 1 mole of copper equals 63.55 grams. Since the mass of aluminum is 26.98, 1 mole of aluminum is 26.98 grams. Now the next thing to think about is compounds. What would the molar mass be of water? I am looking for my eraser here. I hope that this swivel is not making you dizzy. It's kind of an automated thing that's causing the camera to move. So it's making you dizzy any more than my hairstyle could be making you dizzy. I apologize. So I want to talk about the molar mass of water. I hope you like my new hairstyle, by the way. I had a barrette in it, but it didn't really fit very well. This is the first time I've ever tried this color. So the question is, 1 mole of H2O, water, is how many grams? Now what we have to do here is we have to look at the compound formula and look at how many of each element there are. I have 2 waters, or 2 hydrogens, and hydrogen has a molar mass of 1.01 on the periodic table. Oxygen has a molar mass of 16.00. So what we have to do is we have to take the amount for each atom and then add them all up. So we have 2 hydrogens. 2 times 1.01 is 2.02 grams. We have 1 oxygen. 2 times 16.00 is, oh, I made a mistake. I'm sorry. There's only 1 oxygen, so 1 times 16.00 is 16.00. And the total is 18.02 grams. So 1 mole of water is 18.02 grams. Now since a gram of water is equivalent to a milliliter, this is a very small amount of water. If you remember in the video, about 3.5 teaspoons, that's not a lot of water. And to imagine that there are 6.02 times 10 to the 23rd atoms, or molecules of water in a sample of water that is less than 3 teaspoons worth of water. That's crazy. So my next task for students at this point of the lesson was to take all of the formulas that they just calculated and add up the molar masses. So I'm going to pause the video for a second and I'm going to put those molar mass values in. I just have to move this over a little bit. I'm just going to go through one more example. Calcium, when I look on the periodic table, has a mass of 40.08. Fluorine has a mass of 19, and there are 2 of them. So when I take 40.08 plus 19 plus 19, I get 78.08 grams for the molar mass of calcium fluoride. Now one of the important things to be able to do is identify which elements are there and how much. So C2, 2 carbons, 6 hydrogens, 1 nitrogen, 2 oxygens. Sometimes you get a beast like this where you have parentheses and subscripts outside. This 2 here belongs to everything within the parenthesis. So, and it multiplies through. So without it, I have 1 nitrogen and 4 hydrogens. When the 2 is there, it multiplies through. Now I have 2 nitrogens and 8 hydrogens. A common mistake is for students to say that there are 6 hydrogens, but remember it has to multiply through. 1 sulfur, 4 oxygens. Here we have 1 copper, 2 nitrogens, because of that little subscript 2, and 6 oxygens, and then 2 carbons and 4 hydrogens.